Guys, welcome to a new video of organic chemistry. Today we're going over chapter 13 and we're going to be talking about proposing structures for HNMR, right? NMR tells us about like possible structures. It's a type of spectroscopy, right? It will tell us about possible structures we can have. And HNMR is on respect to hydrogen, right? So let's read the question. Propose a structure. So whenever it's talking about proposing a structure, it's talking something like that, right? Propose a structure for compounds with the following formula that shows only one peak in the H1 NMR. So what does that mean? It means that different hydrogens show different peaks, right? So these ones are all the same hydrogens, so they will show the same peak. Let's say if we have something like we have an alcohol in the carbon, right? These two hydrogens will show a different peak. So what they're trying to make us do is if we can recognize what type of peaks can a hydrogen do, right? So this will help us know whenever we're in the HNMR about coupling and stuff like that. So we're giving formulas and we need to propose a structure that shows only one type of hydrogen. So let's see if I rotate this a little bit. So carbon 5H11. Whenever a carbon 5 is proposed, something I like to do. I don't think this is H11, no one alive. So this one is a really tricky one, right? You try that, and if you pull this, that's not gonna work. So what else can we do? Well, we can always put, you know, it's a tricky one because once again, I made a mistake. Really, Jesus? Yes. So this one goes like that. That's two oxygens, right? So why that doesn't work? First of all, the hydrogens are gonna be different. You cannot do that, right? You cannot have that, and you cannot have. So you have 6 hydrogens, so that's why that doesn't work. That's why the other cyclic structure doesn't work. So the only structure that's gonna work, and it's a tricky one. Well, it's not a trick if you think about it. You have, this is a carbon, right? We know that. And we know every carbon has 2 hydrogens. So they are gonna end up with the oxygens make 2 bonds, the carbons make 4 bonds. So everybody made enough bonds and everybody's happy. I know this was a shorter video than the other ones, but this was a simple topic. Let me know if there is any topics in chapter 13 you would like me to explain. I will make a video about HNMR. I just have to research more the topic. I want to give you accurate information when making the video. This is carbon 5H12. H11 will not have made sense. So whenever I get a carbon 5, what I like to do is place it on the center, right? So you can have multiple options. You could have a double bond, you could have a triple bond, you could do like a cyclic, right? Or you could do like, or you could have like the backbone, right? But the one that are most likely to show the same type of hydrogens are these ones, and the cyclic structures, right? Well, you could have, these are the ones that are most likely. They're just the ones that are easier to start with. So this is just like common sense. If you have 12, right? 3 multiplied by 4. You see, 3 times 4, 12. So this is something that came to my mind, right? This is going to look like this. So we have 5 carbons and every hydrogen looks differently, correctly. So now we see 5 and it looks like that. So now we're thinking, wait, we're missing 2 hydrogens. And Jack could be thinking, oh, it might be a double bond, but if you have a double bond on every hydrogen, let's see how that will look. So that's one option you could have, right? A double bond on every carbon. So we have 1, 2, 3, 4, 5. But after that, this carbon has no hydrogens because it has double bond. So, right? So you will have 6. No, you have 4 hydrogens. Well, what if we have one double bond? You already have different type of hydrogens, right? So what I'm gonna go do is do a cyclic structure. So this is 5. So I'm gonna go for pentane. Alright? So I'm gonna do pentane, and in this structure there is the 2 hydrogens, right? Because carbon makes every single one of these are implied carbons, right? These are carbons, and carbons are only making 1 bond and 2 bonds. So you want to have 4 bonds in total. So you want to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are hit and miss. So now let's try this one. Let's try something. These are really hit and miss, right? So we have 4 carbons, 8 hydrogens, right? But it doesn't matter where we put the oxygen because the hydrogens will be differently, right? So if it's too hard, if we put like the oxygen right here, like that makes no sense. So these are trial and error, right? So if a structure is too hard to draw, we have to think about cyclic structure. So you can have carbon, right? And you have 1, 2, 3, 4. So 4 times 2, that's 8. But we're missing an oxygen. So what do you think this structure is gonna be?